move on from there and discuss the next concepts now. Okay, so let's start with our next concept now, and which is factorization. Now, this is tested in both paper 1 and paper 2. So for IGCSE, in both paper 2 and paper 4. So basically, both the papers that you've got, it's tested in both of them. Now, what is major thing here? Factorizing basically means to write things as products. So basically, when you want to factorize something, the result is going to be some things multiplying like this, right? Generally, it's two brackets that you have that are multiplying, right? So for instance, you could have x plus 2 into 2x minus 3. This is a factorized form, okay? This is factorized form. Let me write it down here. When you have things multiplying like this form is called a factorized form. And when you have the same thing expanded with no brackets multiplying like this, that's called the expanded form or simplified form. In this case, that would look like this. It would be 2x squared plus 4x minus 3x, which is plus x minus 6. This is called expanded form or simplified form. And what you have in brackets like this, multiplying, this is called factorized form. Okay. Now, there could be a number of different types of expressions that you would have to factorize. Let's take some examples. Let's take some simple examples. Let's say you want to factorize expressions, simple expressions like this. 5x minus 20. Okay, we want to factorize this. Now, what does that mean? 5x minus 20, this is a simplified form, expanded form. What you want to do is you want to write it in a way that you have two things multiplying like this. Something's multiplying. Now, the way to do it is we think of if there's anything that we can take as a factor here, take as common here, right? Can we take anything common from 5x and minus 20? We can take 5 common, right? If we take 5 common, what are we left with inside? From 5x, we're left with 5 outside. From 20, we're left with 4. And we have this form. This is factorized form, okay? Similarly, if we had something like this, if we had 4x squared plus 32 times x, about this, how do you factorize this? You can take whatever, you can think of whatever you can take common from these two terms, okay? Now, what's common in these two terms? You've got 4 here, you've got 32 here. You can take 4 common outside. That's one thing that you can take common, okay? And then what about the variables? We've got x squared, we've got x. What about the powers of x? We can take x common outside. That leaves us with x plus 32 over 4. That is 8. We're left with x plus 8 inside. This is called factorized form. Okay? So the idea is we try to take common whatever you can. Okay? So you basically see if you can take anything common. That's the idea. Okay? Similarly, you could have something like this. Let's take another example. 10x squared y minus, let's say, 15x y cube. What if you've got something like this? So let's say you've got power 4 here as well. Again, you've got two terms. You think of what you can take common out of these two terms. right? These are the two terms that you've got. What can you take common out of them? Now, you've got 10 and 15. What can you take common from 10 and 15? From 10 and 15, you can take 5 common, right? Okay, and then what about the powers of x? You've got x squared, you've got x raised to power 4. What can you take common from this? You can take x squared common, right? And what about the powers of y? You can take y common. So basically, in variables, you can take whatever is the smallest power common outside. So between y and y cubed, what is the smaller power? Y. You can take that as common outside. And what does that leave you with? 10 over 5 is 2. So you've got 2 left here. X squared is already taken common outside. We can't write that. Y is also taken common outside already. We can't write that. Minus 15 divided by 3. What's that? That's 3. X power 4, we have taken x squared common outside from that already. That leaves us with x squared inside. And from y cube, we have taken y common outside. That leaves us with y squared as the second term. And we have 3x squared, y squared as the second term here. Minus 3x squared, y squared. This is factorized form. Okay, so that's the idea. That's how we can factorize things. Okay, so that's one type of factorization that you would have to do. Now, remember those identities that you've done? You've got 3 algebraic identities and they look like this. If you have a plus b whole squared, you can write this as a squared plus 2ab plus b squared, right? Now, what's the logic behind that? A plus b whole squared is basically just a plus b into a plus b, right? A plus b whole squared is the same thing as a plus b times a plus b. How do you multiply these two brackets? You multiply a with each term in the second bracket. That gives you a into a, which is a squared, plus a into b, that's ab, plus b into a, that's ba or ab. That's the same thing. We are multiplying. It doesn't really matter which one we write first. Plus b into b, that would be b squared. And now these two terms are the same. And that simplifies to a squared plus 2ab plus b squared, right? So that's the reason for this, a plus b whole squared. This basically expands to a squared plus 2ab plus b squared. But now since we have to do this a lot, it often helps to remember this identity so you can expand things directly without having to do all of this multiplication, okay? So this is one identity that we have. Using a similar logic, in fact, exactly the same logic, we have this identity for a minus b whole squared as well. And that looks like this, a squared minus 2ab plus b squared. Again, you can try that by doing a minus b into a minus b. You'll get this from this. And you have another identity apart from these two. And that looks like this, a squared, or you can write it this way, a plus b into a minus b. That gives you a squared minus b squared, right? Again, you can try simplifying this. What does that give you? A squared plus ab minus b squared. And these terms get cancelled out. You're left with a squared minus b squared. And this is what the identity says. You've got these 3 algebraic identities. When you're factorizing stuff, these two also come in handy. The first two, not so much in the factorization process for now. We will see them later when we are doing completing square process at some point. These two are used at that point. But this last one, this is actually used a lot when you have to factorize stuff. Now, what does that mean? A plus b into a minus b, what does that give you? That gives you a square minus b square. But you can also think of it the other way around. If you have a squared minus b squared written somewhere, you can write it in this form, a plus b into a minus b. So all of these identities work both ways, right? You can go this way or this way. This way or this way. They work both ways. So from left to right, we're just expanding things. We're simplifying things. From right to left, we are factorizing them, writing them as products. So this last identity that we have, this last algebraic identity, This is actually used a lot whenever we have expressions that can be thought of as a squared minus b squared form, because then you can write them in a plus b into a minus b form. And that's the factorized form. Now this is used a lot when we are factorizing things as well. Now keep this in mind. And let's look at a few examples where you will see this being applied now. For instance, let's say we've got something like this that we want to factorize. So again, we want to factorize a few expressions. Let's say we've got something like this. We want to factorize x squared minus 49. Now, how can we do that? Can we take anything common from this? Well, we can't. We can't really take anything common from this, right? There's nothing similar between these two terms. So that is not working. What we were trying to do earlier, that's not working anymore. Okay, so that's the first thing that you think of generally when you're factorizing, that can you take anything common? If you can't, then think about this identity. What does this identity say? If you have anything of this form, a square minus b square, you can write that as a plus b into a minus b, right? Now, can you write this in that form? What's 49? 49 is 7 squared, right? So what you can do with this first is you can say this is x squared minus 7 squared. And now this is a squared minus b squared, right? So you have x squared minus 7 squared. So in place of a, we've got x. In place of b, we've got 7. So when you write it in this form, a plus b into a minus b, what is this going to become? This becomes x plus 7 into x minus 7. So using this identity, we can factorize expressions like this sometimes as well. Let's take another example. Let's say we have 9x squared minus 1. We have this expression, 9x squared minus 1. Now, again, we think of whether we can take anything common from these two terms. Just think about it. Can we take anything common? We can't. There's nothing common. We could take 1, but that's not going to help because we have 9x squared minus 1. So again, we think of this identity. Can we use that somehow? Can we write both terms as perfect squares? Can we write them as squares in any way? 9x squared. We could write that as 3x whole squared. We could write that as a square like this, right? So 9x squared is the same thing as 3x whole squared. And what about 1? 1 can also be written as a square because 1 squared is the same thing as 1. So we can write 1 as 1 squared instead. And now we've got that form a squared minus b squared. What that means is we can write this as a plus b into a minus b. So that's 3x plus 1 multiplied by 3x minus 1. And that's the factorized form that we've got. All right. Let's think of another example. So this is how a square minus b square could be used like this. Now, sometimes what you can also do is you can do both of those things. You can take something common as well, and you can write it as a plus b into a minus b as well. Sometimes you can do both of those things in the same expression. Okay, let's think about this now. Let me think of an example like that. So let's say you have you have something like this 11, or let me use some smaller numbers. Let's say you have 6x squared minus 54. Let's say you've got this. Now, how do you factorize this now? 6x squared minus 54. You have to take common whatever you can, and then you can also think of using this identity if that works. Okay, so how do we think about this? First of all, can we take anything common? 6 and 54, we can take 6 common outside. What are we left with inside? X squared minus 54 divided by 6. 54 divided by 6 is 9, right? So now we've got 6 into x squared minus 9. Now we need to think of whether we can factorize this any further. Can we factorize this further? Let's think about it. X squared minus 9. Can we take anything common? We have already taken 6 common outside, so we can't take anything common further. Now think of this identity. Can you use this identity somehow? Are these both perfect squares? X squared and 9? Yes, we can write this as 6 into x squared minus 3 squared. We could write 9 as 3 squared like this. Okay? And now that we have that form, a squared minus b squared, this can be written as a plus b times a minus b. A plus b times a minus b, so that becomes x plus 3 into x minus 3. And that's your factorized form, 6 times x plus 3 into x minus 3. And that's your final answer. If you want to verify this, you can try to expand this thing. You will get the same thing back that we had, that we started from. So this is the factorized form of that expression. Okay. So this is how factorization works when you have two terms that you want to factorize from generally. Okay. All right, let's take another example. Or I think this is enough. In fact, let's take a few examples on cases where you have more than two terms. So when you have 3 terms, for instance. Now this is also going to be used when we talk about solving quadratic equations later on. Factorizing quadratic expressions that may look like this. Let's say you have x squared plus 7x plus 12 equal to 0. Let's say we want to factorize this. Oh, sorry, this is not an equation. That's an expression. We want to factorize this expression. Okay, so how do we think about this? Again, the first thing that you can still think of is, can you take anything common? Well, you can't take anything common from this. Okay, so remember what we're thinking of when we're factorizing. Can we take anything common? First of all, well, in this case, we can't. Okay, so the second thing that we talked about was, can we use this identity somehow? A square minus b square. Well, we only could use that when we had 2 terms. Now, in this case, we've got 3 terms. We can't really use that there. Okay. Now, in cases like these, when you have 3 terms, generally what you have to do to factorize them is you have to break the middle term. This is called middle term breaking method to factorize quadratic expressions. And this is something that we will be using a lot later on to solve quadratic equations as well. Now, how does this process work? Let's think about this. As the name suggests, breaking the middle term, the idea is to look at this middle term and somehow break it down into 2 parts. Okay, we want to break it down into 2 parts. 7x, we want to write it as a sum of 2 expressions. Okay, now how does this process work? You think of the coefficient of the first term and this constant term. So you're looking at 2 terms, coefficient of the first term, which is the square term, and this constant. These are the 2 things that you're looking at. Now, what's the coefficient of the first term? If there's nothing written there, basically means it's 1. What's the constant term? The constant term is 12. You look at these 2 terms, you multiply them. What do you get when you multiply them? 1 into 12, that gives you 12. Now, the idea is we want to think of 2 numbers that when they are multiplied, they give us 12. And when added together, they give us 7. Okay. You want to think of two numbers that when they're multiplied, they give us 12. And when they are added, they give us 7. Now, how do you think about that? Think of all the factors of 12. Okay, how can you get 12? You can get 12 when you multiply 1 and 12. Okay, you can get, so you don't have to write it down generally, but we're just doing it the first time for now. So for that, I'm just writing it down. You can do it in your head mostly later on when you've done some practice. But for now, since we are trying to understand how this works, let's think of all the factors of 12. How can you break 12? You can say that this is 1 into 12. That's one idea. Okay, you can do 2 times 6. You can do 3 times 4. All right. Now, does any of these numbers, let me write it like this: 112, 2, 6, and 3, 4, right? These are three sets of numbers. Do any of these numbers, when added, do they give us 7? We want the middle term when we're adding something. Do any of them give us 7? Well, this last option gives us 7. What we do is, this last option is working because when we add these two numbers, 3 plus 4, we get 7 from that. What we do is, using these two numbers, we break this middle term like this. We say, okay, let's write 7x as 4x and 3x. It doesn't matter which one you write first. You can write 3 first or 4 first. Since I wrote 3, 4 here, I'm just writing it 3x plus 4x plus 12, right? 7 can be written as 3 plus 4. It's the same thing. It's not changing anything. So we have broken the middle term into two parts like this. Now, when we do that, what happens because of this process is, we can take something common generally from the first two terms. So you break it down into two groups of expressions. You've got these first two terms and these third and fourth terms. You look at the first two terms and see, is there anything that you can take common from these two terms? X squared plus 3x. You can take x common from this. Let's write it down. X into x plus 3. That's what you can take common from the first two terms. Then think of what you can take common from the second two terms. Write down, so take whatever you can take common. In this case, you can take 4 common outside. What does that leave you with? That leaves you with x plus 3 inside. And now you notice, this is x plus 3, this is x plus 3. If you're getting the same expressions in both brackets, that's a sign that you've done it correctly. Okay? Because once this happens, that you have the same expressions in both brackets, now what you can do is, you think of these two terms and see, okay, we've got x plus 3 here, and we've got x plus 3 here. So we can take x plus 3 common. When we take x plus 3 common from these two terms, we are left with x plus 3. That's taken common outside. What are we left with from the first term? X. What are we left with from the second term? 4. And we get x plus 3 times x plus 4. And this is the factorized form that we were looking for. Okay? This is our factorized form. Make sense? This is how middle term breaking works. Let's take another example. Let's say instead of this, we had a different expression now. Let me write something down. Okay, let me think of something a bit more complicated. 2x squared minus 7x Oh, let me actually write something down here on this side so that you're not looking. And okay, so if I take these two factors, okay, so we could do 2x squared and 3x minus 4x, that will be minus x minus 6. Let's say we've got this. How do you factorize this now? 2x squared minus x minus 6. Again, these are three terms. We think of whether we can break the middle term. Can we break the middle term here? How does that process work? Multiply 2 and 6. Now, notice the difference that from the last example. In the last example, we had plus here. So what we had to think of was, think of two numbers that when we add them together, we get that middle number that we had there. This sign here is important. In the previous case, it was plus sign. Now, in this case, it's a negative sign. Now, how are we going to factorize this particular expression now? Let's start with the same process. First of all, multiply the coefficient of the first term and the constant term. Ignore the sign for now. Just multiply these two terms. What do you get from that? 2 into 6. Well, in this case, you're again getting 12. Okay. But the middle term this time is what? The middle term is negative x. So basically, what's the coefficient of this? It's minus 1, right? The coefficient of x, the second term, is minus 1. So what you want to do now is think of all the factors of 12. Again, we could have 1, 12, we could have 2, 6, we could have 3, 4, right? These are the three sets of numbers that we could have. What's the number in the middle? The number in the middle is minus 1. Okay, it's minus 1. Now, we need to think of the set of numbers out of these that when we subtract them, where does the minus, why are we saying we're subtracting them? It depends on this sign. If this sign is negative, we have to subtract the numbers. If the constant has a positive sign, we have to add the numbers. Now, this is negative 6. What does that give us? 1 minus 12 or 12 minus 1. What do we get from that? We get 11 or minus 11. Is that what we want? No, we want 1 or minus 1, right? 6 minus 2 is 4. 2 minus 6 is minus 4. Again, that does not work. 3 minus 4 and 4 minus 3. What's that? We can actually use 3 minus 4. When we subtract these two numbers, we get that number in the middle, which is minus 1, and that's what we want. So in this case, what we can do is we can break it down into two parts like this. We can say this is 3x minus 4x. 3 minus 4, and that becomes 2x squared plus 3x minus 4x minus 6. We could break the middle term like this in this case. Now, once we have done this, again, we think of the first two terms and the last two terms. And think of what you can take common from these two terms. Okay, the first two terms, what can you take common? We can take x common. That leaves us with 2x plus 3. What about the third and fourth terms? What can we take common from these two terms? So if you can take negative common, always do that. So if the first term has a negative, you always have to take negative common outside as well. Otherwise, these brackets would not become the same. So if you have in any group of expressions, if you've got negative here, you've got to take that common outside as well. So in this case, if you take minus common outside, what else can you take common? 4 and 6. You can take 2 common outside. What does that leave you with inside? You have 2x plus 3 inside left. We had taken minus common outside already. So inside the bracket, the sign becomes positive, right? Because we've got negative common outside. And now you see this bracket and this bracket, they are again the same. That's a sign that you've done your working correct. And now this turns out to be x minus 2 into 2x plus 3, and that is the factorized form that we were looking for. Okay, so that's how this middle term breaking process works. Let me write down another example. So since we have to do this a lot, you need to make sure that you understand it really well. Let me write down another example. Let's say you've got something like this: 2x squared plus 29x minus 15, and we want to factorize this. How do you think about this now? So think of the factors of the product of 2 and 15 again, and focus on this number. This is negative. So what that means is, since this is a negative sign here, let me write that down here as well. We want two numbers that give us 29 when subtracted. So when we subtract these numbers, we should be getting this middle term. Okay. Now, what's 2 times 15? First of all, let's repeat that process. 2 times 15, that is 30. Now, we need to think of factors of 30. What are the factors of 30? You could say 1 into 30. You could say 2 times 15. You could say 3 times 10. You could say 5 times 6, right? These are all the different factors that you could have. This negative sign tells us what we have to do is we have to subtract these numbers and see if we can get the middle number after that subtraction. Okay, we want 29 when the numbers are subtracted. Well, it's obvious from here that the only numbers that we can use, the only numbers that are big enough to give 29 when subtracted are 30 and 1, because we can do 30 minus 29, and that gives us 1. Sorry, 30 minus 1, and that gives us the result that we need, that is 29. So we can break it down into two parts like this. This becomes 30x minus x minus 1x, right? And the rest of the numbers can be written as they are: 2x squared plus 30x minus x minus 15. Now again, you think of the first two terms and think of what you can take common. Think of the last two terms, think of what you can take common. From the first two terms, we can take 2x common, and that leaves us with x plus 15 inside. And from the second two terms, remember, we have to take negative common always. Can we take any other number common from here? Well, no number or variable can be taken to common here. So we just leave minus 1 here. We can just take minus 1 common. That leaves us with x plus 15 inside. These expressions are again the same. That confirms that this process is correct. You take x plus 15 common from both of these terms now, and that gives you x plus 15 times 2x minus 1. And that's the factorized form that we've got in this case. All right. So this is how this factorization process works. Okay, just give me a second. Okay, Vicky is trying to join, but there's some problem with the waiting room apparently, so I'm just checking what it might be. Okay, so that's fine. Let's do one more example on this. Let's say we've got something like this. 2x squared plus 7x minus 6 equal to 0. All right. Sorry, not equal to 0. We want to factorize this now. What about this? Again, we can start with thinking, can we take anything common from all of these terms? Well, we can't. Now, we think of breaking the middle term. How can you break the middle term in this case? 2 into 6? Well, again, we've got 12 in this case. But this is a good example. I wanted to particularly do this because it clears one concept that when we multiply 2 and 6 here, we get 12 here. What are the factors of 12? The factors of 12 are 1 into 12, or we could do 2 and 6, or 3 and 4. Now, we want 7 in the middle, right? Now, a very common mistake that might happen could be that you break it down like this and you say, this can be written as 2x squared plus, since 3 and 4, when they're added together, they give us 7. You might think that it becomes 2x squared plus 3x plus 4x minus 6. But in this case, this is not going to work. And you can realize that in the very next step after this, because now when you take something common here, you take x common, that leaves you with 2x plus 3 from the first two terms. And from the third and fourth terms, when you take 2 common, what are you left with inside? You're left with 2x minus 3. And now you see the two brackets that you've got, they are not the same. One is 2x plus 3 and the other is 2x minus 3. Now don't try to make them the same by force. They are not the same. That means you've done something wrong. So what's wrong in this process? Can anyone tell me what's wrong in this process? Isn't this the correct way to break the middle term? I've broken 7x like 3x plus 4x. What's the problem with this? Any idea? Yes, the problem is this sign. This sign that we've got, this is negative, right? This is negative. Now, since this is negative, what that means is we cannot add two numbers and get that middle number. We have to subtract two numbers to get that middle number. Okay, this middle number should be something that we get by subtracting the numbers. Now, amongst these factors, is there any that you can subtract and get 7 from that? Well, no. 12 minus 1 is 11. 6 minus 2 is 4. 4 minus 3 is 1. None of them give us 7. That means we cannot factorize this. This expression cannot be factorized. This is not going to work. Okay? Because the sign there was minus. We had to get 7 by subtracting two numbers and not by adding two numbers. So this expression can actually not be factorized. And if you were to solve an equation involving this quadratic expression later on, which you might see later on, you will see that you would have to do it using the quadratic formula. Factorization is not going to work on this. All right. Okay. Now that's how it works when you have a number and one variable like this. Now, sometimes what happens is you have terms like this instead. You have three terms, but there are not all numbers. You've got something like this, for instance. You have x squared minus 4xy minus 12y squared. What if you got something like this? And again, what you want to do is you want to factorize this. How do you think about this now? Again, what's the first thing that we think of? We think of whether we can take anything common from this. We can't. Can we use that identity a square minus b square? Again, this is three terms. We cannot use that. We can think of breaking the middle term. How do we do that? It's slightly different from the previous examples because in the previous examples, we only had x there. But in this case, we also have y, right? Now, how do you deal with this y? You just think of the numbers first of all. Just like before, forget about x and y for now. Just focus on the numbers that you've got. This is 1 and this is negative 12. Just think of those two numbers. You've got 12. How can you get 12? 12 you can get by using, again, the same numbers, 1, 12, 2, 6, 3, 4. This is negative. So you want two numbers that when they are subtracted, they give us negative 4. Now, do any of these numbers when subtracted give us negative 4? 2 and 6, right? We can use that. We can say that is 2 minus 6. That gives us negative 4. That's what we can use here. We can say the middle term can be broken into two parts like this so that it becomes 2, and then these two variables come down as it is, xy minus 6xy. We can break it down into two parts like this. And then the rest of the terms, they're just copied down as they were. And now we see, can we take anything common from the first two terms? And can we take anything common from the last two terms? Just like before. From the first two terms, we can take x common. That leaves us with x inside minus 2y. And from the third and fourth terms, we can take minus 6y common. And that leaves us with x plus 2 times y inside the bracket. Okay, sorry. This is negative. This is negative. Okay, I'm sorry. I wrote this negative here. This was plus actually. So this should have been plus. So yeah, x plus 2y. So I noticed I did a mistake. How? Because these brackets were not turning out to be the same. That means I had done something wrong. So it turns out when I wrote here 2xy minus 6xy, I by mistake wrote minus here. This should have been plus. So that becomes x plus 2y. Now the brackets are the same. This bracket and this bracket, they're both the same. We take x plus 2y common. And that leaves us with x minus 6y in the other bracket, and that's the factorized form for this expression. Okay, so when you've got three terms, generally what we do is we factorize those expressions of using the middle term breaking method. Okay, you break the middle term. How do you do that? You multiply the first and last terms, the numbers there. You think of all the factors that when added or subtracted, depending on this sign, can give you the middle number. Using that, we break that middle term. All right. What if you've got more than three terms? That can also happen sometimes when you have four terms in an expression and you want to factorize that expression. Let's take an example. You could have something like this. You want to factorize 3tx minus 2sx plus 15ty minus 10sy. Let's say you want to factorize this now. You've got four terms in this case. Now, you could again think of whether you can break the middle term. Well, but can you do that? There's no middle term here because now you've got four terms, right? So there's no middle term as such. Okay, we've got four terms. How do you factorize this? When we have four terms like this, we can think of it as something that is already, that for which we have already kind of broken the middle term, right? So think of the second step in this process. It's like you've reached this second step already, which means you just have to look at the first two terms and the third and fourth terms and see, can you take anything common from the first two terms and can you take anything common from the third and fourth terms? And then just using that, you factorize this. So in this case, for instance, from the first two terms, is there anything that we can take common? Yes, we can take x common from the first two terms. That leaves us with 3t minus 2s inside. Now, from the third and fourth terms, is there anything that we can take common? First of all, from numbers, 15 and 10, we can take 5 common, right? And then from these letters, ty and sy, y is common. We can take y common. What does that leave us with inside? 15 over 5 is 3. Y is taken common outside. We have t left there. 10 over 5 is 2. Y is taken common outside. We've got s left inside. And now you see these two brackets are the same, which means we can take 3t minus 2s common. And then x plus 5y, what's that going to be? That's going to be in the other bracket. And that's your factorized form. When you have four terms like this, what you can do is you can just take something common from the first two terms, take whatever you can take common from the second two terms, and then you write it like this. Okay. I hope that makes sense. Now let's move on and just do one more example, and then we talk about quadratic equations quickly. Let's say you've got something like this. You want to factorize 2yt plus 4zs minus 8ys minus zt. You want to factorize this now. Any idea about this? How is this going to work? How do you factorize these four terms now? Two yt plus 4zs minus 8ys minus zt. Any idea about this? Can we take anything common from the first two terms? Well, we can't. Can we take anything common from the third and fourth terms? We can't. So sometimes you end up getting expressions that look like this, in which you cannot take anything common outside, right? Now, what do you do with them in such problems when you have four terms like this? You rearrange them. So you can write one of these terms first, another term second, or so you can basically shuffle the terms in a way that the first two terms will give you something common and the third and fourth terms will give you something common. Okay. So for instance, we've got 2 by t here. What I can try to do is I can rearrange it in a way so that I have one term that has y or t in it next to it. So I can either take this and write it next to it, or I can write this next to it, right? Because both of them have something common with it, right? So I could do it like this. For instance, I could say it's 2 by t minus 8ys plus 4zs minus zt. So I can rearrange it like this. And now we look at the first two terms and we look at the third and fourth terms and see what we can take common. From the first two terms, we can take 2y common. That leaves us with t minus 4s inside. From the third and fourth terms, can we take anything common? We can take z common. And that leaves us with 4s minus t common. Okay, that's interesting. What do we do now? Do we have the brackets the same? Well, they're not the same. One is t minus 4s and the other is 4s minus t. They're basically negative of each other. For instance, if I multiply t minus 4s with minus 1, what do I get from that? I get 4s minus t. So if I multiply one of them by minus 1, I'll get the other one. How can I make these two brackets the same now? How can we make these two brackets the same? What we can do is we can take minus common from this outside. Take minus common from this. When you do that, what are you left with inside? 2y into t minus 4s. Since these two brackets are not the same, that's a problem. We want the brackets to be the same. However, we notice that they are negative of each other. If one is t minus 4s, the other is 4s minus t. If I take negative common from the second bracket, I have minus z outside. Inside, it becomes minus 4s plus t. That's the same thing as t minus 4s. And now the brackets are the same. I can take t minus 4s common. And 2y minus z will be in the other bracket. This is how we could factorize this expression. This is as complicated as it could possibly get. And that's our final answer. Okay. So this is how factorization process works. Now, using the middle term breaking method in particular, we would also need to be able to solve equations. Okay, so we've talked about how factorization works. You can do all problems involving factorization now. Now, in the next class, we will discuss quadratic equations in detail, including the completing square method, inshallah, how to solve quadratic equations using quadratic formula, using factorization, using completing square. But just to give you a quick idea about that, let's say we have an equation to solve, which looks like this. X squared minus 7x plus 12 equal to 0. We want to solve this equation. Okay, it's a quadratic equation. How do we solve this quadratic equation? In the first few steps, we will be doing the same thing that we did when factorizing expressions like these. Okay, so what we do is we factorize the left-hand side. We factorize the left-hand side. How do you factorize this? These are three terms. We break the middle term and see what we get from that. 1 into 12, that is going to give you 12. What are the factors of 12? 1, 12. 2, 6, 3, 4. This is plus. What that means is when I add two numbers out of these, I should be getting 7 from that. I'm sorry. Something wrong with one note today. Okay. So when we add two numbers from these, we should be getting 7. Now, which numbers can we use? We can use 3 and 4 again, right? 3 and 4, when added, they give us 7. So 3 and 4 are going to work. But how exactly do we add them? Because we want -7 eventually, right? So we do it like this. We say 3 plus 4, and then we have a minus sign outside like this. Or in other words, it's -3 minus 4, because that is what is going to give us -7. You can break it down into two parts like this. This becomes -3x minus 4x plus 12 equal to 0. The middle term is broken. Now the left side can be factorized. From the first two terms, we can take x common. That leaves us with x minus 3 inside. From the third and fourth terms, we can take -4 common. That leaves us with x minus 3 inside as well. Take x minus 3 common from these two terms. What are we left with? X minus 4. This is your factorized form. Now, what we wanted to do was, we wanted to solve this equation. X squared minus 7x plus 12 equal to 0. Now, solving means we want some values of x. We want x equal to something, x equal to something. Generally, in quadratic equations, we get two solutions. Now, what are the solutions from this? We have factorized the left-hand side already. Remember, in factorization process, we just want to write something in this form, x minus 3 into x minus 4. Now, we have written that in this form. The factorization process is done, but we actually wanted to solve this equation. Now, how do we solve this equation? We've got x minus 3 into x minus 4 equal to 0. Now, think about it. You've got two numbers, two expressions multiplying, and the result is equal to 0. You've got two expressions multiplying, and the result is equal to 0. How is that possible? If you multiply any two numbers, when can the answer be 0? When can you get 0 as a product? When either the first one is 0 or the second one is 0. At least one of them has to be 0. Otherwise, the product cannot be 0, right? Any two numbers, if none of them is 0 and you multiply them, the result will also not be 0. For the product of two expressions or two numbers to be equal to 0, either the first one should be 0 or the second one should be 0. What that means is, when we have reached this point, we say either x minus 3 is equal to 0, then this equation could satisfy, or x minus 4 is equal to 0. That's the other case in which this equation could be satisfied. Now, the first one gives us x equal to 3, and the second one gives us x equals 4. These are the two solutions that we have got for this equation, either x equals 3 or x equals 4. Okay? So that's the idea. When we solve quadratic equations, what we try to do is we try to factorize the left-hand side. When we have factorized it, when we have this form, two things multiplying, and the result is equal to 0, that means either the first one is equal to 0 or the second one is equal to 0. That means we can find the values of x from that. Okay? Let's take another example. Let's say we had some, so whatever equation that we've got, we will basically be factorizing the left-hand side first. Let's say we had, let's just take one of these examples that we had before. Yeah. 4x squared minus 14x. plus 14x minus 12 equal to 0. We want to solve this equation now. Now, how do we solve this equation? First of all, we can see if we can factorize the left-hand side. Now, how can you factorize the left-hand side? Can you take any number common? You can take 2 common. That leaves you with 2x squared plus 7x minus 6 equal to 0. You can actually simplify this equation by dividing 2 on the other side in this case. And that leaves you with just 2x squared plus 7x minus 6. And now you think of whether you can factorize this. We did this before. We can do it like this. It becomes 2x squared plus... Okay, I'm sorry. This can actually not be factorized. If we had a plus sign here, will that work? With a plus sign, so if we had a plus sign here, that would work. So let's say if it was like this. Now, 2x squared plus 4x plus 3x plus 6 equal to 0. The first two terms give us 2x into x plus 2. Then we have 3 into x plus 2. And then we have two factors, x plus 2 times 2x plus 3. That equals 0. Now, what does that mean? We've got two things multiplying. The result is 0. That means either x plus 2 is equal to 0 or 2x plus 3 is equal to 0, because for the product to be equal to 0, at least one of them has to be 0. Now, the first one gives us x equal to minus 2, and the second one gives us x equal to minus 3 over 2. These are the solutions of this equation. All right. Sometimes you get the factorized form directly in the question as well. So you could have, for instance, 3x minus 4 into x plus 5 equal to 0. And they might ask you to solve this equation. Now, how do you solve this equation? You've got the factorized form already, so they've given you this form already. You say, okay, either the left-hand side is equal to 0, which means 3x minus 4 is equal to 0, or x plus 5 is equal to 0. The first one gives you x equal to 4 over 3, and the second one gives you x equals minus 5. And these are going to be answers to this equation. Okay. Sometimes you might be asked to solve equations like this. You could have x minus 2 into 2x plus 4, and let's say that is equal to 4. How do you solve this equation now? X minus 2 into 2x plus 4, that is equal to 4. This is an equation that we want to solve now. Now, how is this going to work? This is different from the previous example. In the previous example, we had 0 on the right side. In the second example now, we've got 4 on the right side. Now, that logic that we discussed earlier, that when two things are multiplying and the result is equal to 0, it's necessary for one of them to be 0. That no longer works in this case. We have two things multiplying and the result is equal to 4. It's not correct to say that either x minus 2 is equal to 4 or 2x plus 4 is equal to 4. That would be wrong. You cannot do it like this. Why can we not do it like this? Because, again, use the same idea as before. You've got two things multiplying and the result is equal to 4. If on the other side we had 0, then it would be necessary that either the first case is 0 or either the first expression is 0 or the second expression is 0. It would be necessary for one of them to be 0 if we had 0 on the other side. But now we've got 4 on the other side. Can we write two numbers in these boxes such that none of them is 4 and the product is still 4. There are many possibilities that we could have here. One simple example could be that we've got 2 and 2 here. None of them is 4, and the product is equal to 4. So it's not necessary that at least one of them has to be 4. We cannot do it like this. Okay, there are many other possibilities as well. Apart from 2, you could also do something like this. You could have 8 here, and you could have 0.5 here. That also gives you a product of 4. Okay, so it's not necessary for any one of those brackets to be equal to 4 in this case. We could only use this idea when we had 0 on the other side. With any other number apart from 0, we cannot do it. So how then are we going to solve this? We would have to expand this instead. We have to multiply x minus 2 into 2x plus 4 on the left side. The expression that we got on the left side, we would have to multiply that. X into 2x, that becomes 2x squared plus 4x minus 4x minus 8 equal to 4. Now, in this case, 4x and 4x, they get cancelled, and we're left with 2x squared minus 8 equal to 4. 2x squared equals 12, x squared equals 6. And now we take square root on both sides, but remember, whenever we take square root, we have to put plus minus. So it's x equals plus minus square root of 6, and that's your final answer from this. This is the solution. If you want to write this in decimals, you can do this on your calculator. Square root of 6. That is 2.449 to 3 significant figures. That would be plus minus 2.45. And these would be the two solutions that you got for this, 2.45 and minus 2.45. Okay, this would be the correct way of solving this equation. We would have to expand the left-hand side and then solve it. In this case, the x terms got cancelled. Generally, they would not get cancelled. In that case, you could use the middle term breaking method if that works. Or if not, we could use the quadratic formula, which we'll talk about in the next class, inshallah. Now, in the next class, we'll talk about how to solve quadratic equations using different methods. Completing square, quadratic formula, factorization, and if we have time, we might also talk about solving simultaneous equations. All right, that's it for today. If you have any quick questions, you can let me know. Otherwise, we will end this here. Any problems, anyone? Any questions that you might want to ask? Okay, I'll be uploading a worksheet for this as well. Please start attempting that. Two, in addition to indices, the indices worksheet was already uploaded earlier. Please make sure to complete that if you haven't already. I'll be uploading worksheets on factorization and quadratic equations as well. You can start working on them. Practice is key. Make sure that you're doing that. Do a lot of practice. And it's not that difficult. You should all be able to do that. Okay. Just an announcement. I actually have a meeting at one of the schools where I teach tomorrow, due to which I will not be able to take my class tomorrow. Take this class tomorrow. Instead of this, we will have to reschedule this to Friday. Okay. So same time, instead of Thursday, for this week, just for this week, we would have to move our class to Friday. Okay, there's a meeting at a school which I need to attend. So instead of tomorrow, we will be doing Friday this week, inshallah. All right, Friday 4 p.m. Pakistan time, as usual. I'll see you again on Friday then. Allah Hafiz.